Okay, so this is, again, 5.6.1 test review. This is part C. And this is very much like the last one that we did, except that the mass is 4 times greater and the radius is 2 times greater. So I'm going to do the same thing. So I have the mass of the planet is 4 times the mass of Earth. The radius of the planet is 2 times the radius of Earth. And I'm going to plug that in. So I have G over RP squared, which is G for M over 2R squared. So I have 4 GMM over 4R squared. My 4's are going to cancel, and this looks just like the formula. So that's going to be this one. Okay. So this says an astronaut travels to a position that is a height of 2r above Earth. So I have Earth. I'm going to have to do this sideways. Here's R. He is 2r. So the total is going to be 3r. At this height, the force of the Earth's gravity is blank, its force at the surface. So again, I'm going to use this. And the masses don't change. That's all going to remain the same. But down here, I'm going to plug in 3r squared, which gives me 9r squared, which is 1/9. So that's how I get B. Okay. Let me change colors. It says Earth's radius is this. An object is dropped from a height this above the Earth's surface. What is the initial acceleration in terms of g? Okay, so this is kilometers. So I have to convert it to meters. And then I have my distance, which I also have to convert to meters. This is pretty ugly. So what I did was I said, okay, F, G, 1 is equal to GMM over R squared. And then FG2 is equal to GMM over R plus D squared. And I divided them. So I'm looking for this one. So I did, okay, G1 over G. That's not right. I'm not looking for this one. Never mind what I just said. Is equal to GMM over R squared over GMM over, oops, wrong. Erase this. Go back to my pen. This is R plus H D. Squared. R squared. So these cancel, and I end up with R squared over R plus D squared. Which, when I plug in numbers, so I have G1 over G is equal to 0.8302, and I'm going to multiply this G over here so that I get G1 equals 0.3. which is this one. That was a rough problem. Oh, planet Z. Okay, this one also threw us for a loop, but okay. Oh, and we're going to use quadratic. Awesome. So what I did was I said, okay, I have f times 0.48 is equal to f above the surface. Okay, so this is gm over r squared, because my little m's are going to cancel out, times 0.48 is equal to gm over r plus, and this has to be converted to meters, so we have 3240 and 3 zeros, which is meters. So this is 1, 2, 3, and that's squared. These are going to cancel. And I get 0.48 over r squared is equal to 1 over this. Okay, and then I'm going to cross multiply this. So I get r squared is equal to 0.48 times 1, 2, 3, 4. Oof. So then I've got to FOIL this, and I get, when I FOIL it, excuse me, r squared plus 1, 2, 3, 4 r plus 1.049 times 10 to the 13th. Okay, then I have to distribute my 0.48. So I get 0.48 r squared plus 3.0400 r plus 5.0838 times 10 to the 12th. Lots of room for error here because you're multiplying big numbers. So I'm going to combine my like terms so that I have 0. And what you're going to see is these are going to become negative and this is going to become positive. So the step I'm skipping is to multiply through by a negative. Because if I subtract this, I get negative 0.52, and I don't want my a to be negative. I want it to be positive. So okay. Now we use the quadratic formula. So let me change colors and see if we can find a spot on here to do that. Where my a is going to be 0.52, my b is going to be negative 31104. And my c is going to be negative 5.4. Okay. Let me show you what that looks like. So that looks like, keeping with the, and we're solving for r, so that's going to be b plus or minus the square root of b squared minus 4ac over 2a. So that's negative 3110400 plus or minus the square root of negative 3110400 squared minus, come on, minus 4ac that's square root all over 2 times, and what I get is I get 7307383.89 meters, but all of my answers are in kilometers. So I divide this by 1,000, and I get this, which is this one. Okay. So this is a definition that I found on page 30 of 55 of lesson 5.5. So the end of this lesson starts to talk about different astronomers, and it's right before that part. But this is, where did my thing go? Is it gone? There it is. This is directly the definition of this. Okay. Okay, so here, what's interesting is it asks for 2 questions, but you're not going to answer this one. Don't know why, because this is what they asked. This is what the answers are, is the centripetal acceleration of Moon 2. So t is equal to 2 pi r over v, and we're going to solve for v. So let's see. So I have this, and I have this. So I have 3 times 10 to the 5th is equal to 2 times 3.14 times 9 to the 7th over v. So I solve for v, and I get this. And then I use this to find my centripetal acceleration, plugging this in for velocity over the same, and I get 0.040 meters per second squared, which is c. Okay. This was interesting. So in the 1960s, the Soviet Union launched a satellite into a nearly circular orbit around the Earth. One commentator expressed a concern that the satellite could drop a nuclear bomb on the United States. If in fact the orbiting satellite could release a bomb, how would the bomb travel? So keep in mind that there is no propelling force. The satellite is literally, so here's my satellite, is literally dropping something. There's no propelling force. So as this drops, it's not a missile, it's just like a rock. It's just going to remain in orbit with this, which is A. Okay. This one may take longer than 2 minutes to do. Alright, so what is the mass of planet Q given all of this? And I grabbed let me go ahead and start this on the next one.